Top 5 of the most void and supervoid places in the universe. In the observable universe, there are very mysterious objects such as emission galaxies, neutron stars, or supermassive black holes. But just as these famous objects can be full of mysteries, questions can also arise when we find places where there is absolutely nothing. After all, why should there be a void in the universe? These are the 5 most terrifying voids in the universe. Okay, curious people, time to test that knowledge. What did King Tut, Pope Gregory VII, and John D. Rockefeller have in common? Ding, 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 they all invested in art. That's right. In fact, the Rockefeller art collection recently sold for $800 million at auction. Thanks to today's sponsor, Masterworks, you don't need millions to invest in blue-chip art. Art has unusual risk-reward investing characteristics. What do I mean by that? Well, because art has outperformed the S&P by 164% from 1995 to 2021, while exhibiting low correlation to any asset class. Masterworks is the first art platform making this asset class available to investors like you and me. They acquire multi-million-dollar paintings by famous artists like Monet, Picasso, and Warhol, and allow you to buy shares that represent an investment in the painting. And these guys know what they're doing. In 2020, they returned 32% to investors, and in 2021, they returned 31%. And luckily for you guys, I've partnered with them to give all of my viewers priority access to invest in their newest offerings. Invest in history with the future. Invest with Masterworks. By definition, an astronomical void is a space with few or no galaxies in it. These voids and galactic superclusters are the most significant things in the observable universe, as they can measure several 100 million light years. In addition, they are considered very rare since scientists fail to reach a consensus on how they are formed or how much they can grow. Number 1. Taurus Void. The first of these is the supervoid of Taurus, an immense region of almost void space located between the supercluster of Perseus Pisces and the supercluster Virgo. The Taurus Void is unique because of its relative proximity to Earth. Because being the closest supervoid to Earth, it is tough to study because it is located behind the evasion zone called ZOA, which is the area of the sky obscured by the Milky Way. Everything behind the evasion zone is practically invisible to our telescopes, since the greatest concentration of stars is located that block with their light all the objects at a greater distance. It's like wanting to see a firefly behind the lights of the floodlights of a football stadium. But how do we know that the area is void if we can't see it? Scientists in charge of research in this region of the sky have always had problems determining the diameter and density of the Taurus Void. Still, it has been possible to observe this area previously with spectroscopes. Spectroscopes are special telescopes equipped with lenses capable of seeing frequencies of radiation that our eyes do not perceive, such as ultraviolet light, infrared light, among many others. The infrared light region is where there is minor foreground extinction of the Milky Way. Observing in this region, we can see through all the stars that are concentrated in the center of our galaxy. Thanks to this, it was established that the void of Taurus is a void. In addition, other studies have mapped the void, and it has been shown that there is a rate of exit of galaxies from the void to the outside of it. That is, galaxies move away from the Taurus Void, moving in the opposite direction to the center. Our galaxy, the Milky Way, also continuously moves away from this void. But why? The voids are thought to have been caused by oscillations of matter during the Big Bang. Mass collapses followed by implosions. These oscillations resulted in slight differences in mass distribution in the early universe that grew over time. The dense areas collapsed more rapidly under gravity and created the foam-like structure of the filaments and voids of galaxies we observe today. In contrast, the areas that imploded did not form the filament of the galaxies, leaving them completely void. In this way, the galaxies are grouped into galactic clusters, while the voids remain more and more void, since the galaxies inside them are attracted by the concentrations of matter outside the void. Number 2. Local Void. This is a vast void region of space adjacent to the local galactic group. It was discovered by American astronomers Brent Tully and Rick Fisher in 1987. Thanks to their investigations, it is now known that the local void is composed of 3 sectors separated by bridges of very faint galactic filaments. That is to say that in the middle of the void, there are regions with very few tiny galaxies. This means that the voids are not completely void, but are much less dense areas than the rest of the universe, which is still something very rare for cosmologists who study the evolution of the cosmos. Thanks to this void, astronomers have noticed that the Milky Way is located in a large flat matrix of galaxies called the local leaf, which borders the local void. The local void extends approximately 200 million light-years starting at the edge of the local group. It is believed that the distance from the Earth to the center of the local void must be at least 75 million light-years, but we are moving away from it quickly. The size of the local void was calculated due to the dwarf galaxy ESO 461-36, located inside. This galaxy travels at 135 miles per second through the local void to an area where there is another group of galaxies outside the void. By comparison, the Milky Way and its neighboring galaxies in the local cluster are moving away from the void at 175 miles per second. This is because the void, as the name implies, lacks matter and therefore has no influence of gravitational attraction on other galaxies that leave the voids emptier and emptier. The larger and void a void is, the weaker its gravity and the faster galaxies within it flee to areas with higher concentrations of matter. However, it has been observed that the dwarf galaxy ESO 461-36 that lies within the local void is moving strangely fast, and some cosmologists are giving rise to the theory that perhaps these regions have a significant dominance of dark energy, which would accelerate the galaxies, causing them to be ejected faster from the voids. Number 3. Boötes supervoid. This is one of the most studied voids in the universe because it is one of the largest. The Boötes Void was discovered in 1981 and is located near the constellation of the same name. At 250 to 330 million light-years across, the Boötes Void is one of the most enormous voids we have ever discovered. So far, 60 galaxies have been discovered in the Boötes Void, so it's not entirely void. As we mentioned before, the voids are not 100% void since they have galaxies inside them. However, they are highly void regions if we consider that in a radius of 330 million light-years, there should be between 2,000 and 3,000 galaxies, but in the Boötes Void there are only 60. That's less than 1% of what's generally in such a large space. What happened to the other galaxies? Where did they go? What caused them to get out of there? Is anything inside the voids that causes galaxies to fall out of place? Are those galaxies there, but we can't see them? All those questions still don't have a clear answer. Studies indicate that the 60 galaxies found within the Boötes Void are concentrated in a tube-like line that runs through the entire void. So many researchers think that the merger of several smaller voids most likely formed the Great Boötes Void. This would mean that the network of galaxies that we can observe in the universe are directly related to the voids that can also merge to create larger, more massive voids. Number 4. Eridanus supervoid. The Great Eridanus supervoid is an area that can exist between us and the cosmic microwave background, CMB. Although there is evidence of its footprint in the form of cold, its existence is still debated. When observing with radio telescopes, traces of galactic clusters have been detected inside. What is not known is how dense these clusters are and how many there are. In supervoids like this, the temperatures are much lower than usual. This can be seen in the image of the cosmic microwave background, where the areas with the highest density of galaxies are marked with the color red, while the areas with the lowest density of galaxies are represented with the color blue. In turn, the areas with the highest densities of galaxies are also the hottest, and the areas with the lowest density of galaxies are the coldest. This means that if there are a large number of galaxies or cosmic dust inside the voids, they may be so cold that our telescopes are not able to detect it since they hardly emit radiation. Scarce objects have been detected within the supervoids called void galaxies, consisting of galaxies whose star population is extremely low, but their behavior is that of a galaxy. These void galaxies are naturally cold and difficult to detect. If they exist in a large proportion within this supervoid, then it would have much more matter than we can see with modern technology. The voids within the local group are relatively close to less than 800 million light-years. Being so close to the Milky Way, it is possible to determine its density. Still, in the case of the supervoid of Eridanus, it is 10 billion light-years away, so it is impossible to estimate its density with modern technology. We will have to wait for images from much more powerful telescopes, such as the James Webb or the Very Large Telescope, to solve these mysteries. Suppose this void is indeed as large as estimated to be one of the most significant structures in the observable universe that would measure approximately 150 to 300 megaparsecs. In that case, this is equivalent to a diameter of between 500 million to 1 billion light-years. Number 5. Canis Venatici supervoid. This is the most significant supervoid confirmed to date, with an estimated diameter of 300 to 400 megaparsecs, i.e. 1,000 to 1,300 million light-years. The Canis Venatici supervoid was discovered in 1988 and is even more significant than the hypothetical Eridanus supervoid. Although it is a large void, there are 17 galaxy clusters concentrated in a spherical region of 50 megaparsecs in diameter. Studies of the motion of clusters show that they do not interact with each other, which means that the density of clusters is very low, resulting in weak gravitational interaction. As with other detected supervoids, this one also presents a pattern in which the galaxies inside accumulate in a network of galactic filaments moving away from the center of the void at high speed. Extra, the KBC Void. The KBC Void is theoretically the largest known supervoid. However, like the Eridanus supervoid, it is still debated whether this zone is a void or not. It has been shown that galaxies within a void experience a gravitational pull from outside the void, which produces a higher local value for the Hubble constant. Remember that the Hubble constant is a cosmological measure that helps us determine how fast the universe expands by measuring the redshift of galaxies. Some researchers have proposed the KBC structure as the cause of the discrepancy between the Hubble constant measurements using galactic supernovae and Cepheid variables and the cosmic microwave background to measure the expansion of the universe, which would mean that the Milky Way and the entire galactic local group of which we are part of are located right on the edge of supervoid KBC. However, other work has shown no evidence of this in observations, finding that the scale of the supposed galactic subdensity within the supervoid KBC is incompatible with observations extending beyond its radius. This would mean that this region is not void, but rather moves at a different speed from the rest of the galaxies in the universe. For now, this is still under debate. If the following technologies show us information about this region of the sky and it turns out that KBC's supervoid is real, this would have a diameter of at least 2,000 million light-years, which would make it not only the emptiest area of the known universe, but also the largest structure in the entire universe. Can you imagine that? The biggest thing in the universe would be a bunch of nothing.